Well, we've got 15 projects happening, STEM projects, in the science rooms, technology rooms and art rooms, so we can go and see a few of them as we go.
Here at Mulberry School for Girls, it's day 3 of a week of cross-curricular STEM project work.
In here we've got STEM 6, which is the future food. They're having a tomato fest, so they've been exploring varieties of tomatoes, how we can grow them sustainably. This week is our very first themed week, and it's called How Should We Live Now? And at the root of that is ideas about sustainability. This one's called No Such Thing as Waste, and they're looking at composting. We've got 15 groups running STEM sustainability projects, which represents about 300 girls. These are the green shoppers, and this project is maths-led, so they've done quite a lot of analysis of the kinds of things people might have in their shopping trolleys. We're exploring vertical groupings, we're exploring cross-curricular collaborations. This is the big wardrobe, looking at clothing and other household object recycling. The idea of closed-loop thinking has been really at the basis of all of our 15 projects that are running this week. The Nuffield materials have really given us a framework for thinking about that in terms of closed-loop thinking.
Way, we're getting water pumped.
For STEM Group 7, science teacher Sarah Elston has used the materials to introduce the theme of sustainability and closed-loop thinking.
So on the first day, we used the introduction bit about the oil production and population growth and the comparison between the two. So we talked a bit about the fact that the oil was running out and the effect it would have on the world, and the fact that what we used all the oil for, so that we could introduce the idea of a closed loop system and apply it to what we were doing in this particular project of finding energy for growing.
For a crocodile.
These students are working together as part of a school-wide consultation for a project where the aim is to power the school greenhouse in a more sustainable way.
We have 2 greenhouses that are attached to 2 science rooms that are sitting on the side. They have a hydroponic growing system that we have had installed in them. So we have this system that pumps minerals through the granules for each plant. So there's an electric pump that is running the minerals round through the system all the time. We also have, as you can hear, a fan that goes on to keep an air circulation, also keep it cooler in here because they're quite hot greenhouses. So there's quite a lot of electricity that is needed. So what we're trying to do is find a different way to get that energy, and we're hoping to be able to get solar panels and maybe even a wind turbine that will give us the energy that we need so that we're not taking more energy from the grid.
Or do you put it negative? Put it negative. Exactly what put it in negative one. Trying to find a way to power solar panels. If you put light on them, then it creates energy. And instead of using electricity, we use the energy of the sun, like natural energy.
So what we've got going on in this room is all of the different groups are busy operating, working away. In this area here, we've got the research group. They're the group that are busy finding out information about solar panels and wind generation. The group over there are doing the electric circuit building. So they're putting together the solar panels to drive tiny little fans, just to represent the solar panels on the roof and the fans in the greenhouses. And then we've got the building modelling group. They're actually making a model of the building where the solar panels are going to go. Over there is the group that are working on the presentation to explain the project and also explain the bigger picture of what this project is about. Modelling the real thing, closing the loop, making our greenhouses self-sufficient. That's the plan. This is the greenhouses that we've got. We're looking at them now from the outside, and this is where we're installing solar panels, not actually on the greenhouses, because that's not the best place for them. The best place for them is actually over here on the walkway there.
This is the science walkway, and we're modelling this part because we want solar panels to go on because it's going to for the greenhouses. So, and we're adding details so that the students know what part of the school it is.
The model itself is going to be a great educational tool. The model will tell the rest of the school what we're doing. They really are starting to get the language to be able to communicate the kind of thinking that we're doing out to the rest of the school.
But they're up there.
The groups basically chose themselves more or less because they're from years 7, 8, 9, 10 and so they don't know each other. You get a sense of group work in a different way than what they normally do within their classes.
We want to put the solar panels on the roof. Yeah, so how long do you think the roof is going to be?
It's 1 metre, 70 centimetres.
They're having to kind of communicate across the groups as well, gathering more information. So for instance, the building modelling group have had to use their math skills to scale down the real full-size walkway to a certain size that would have fit on their piece of red card that is our baseboard.
It's good because it's teamwork and it's quite a big project and we needed like lots of people working on it together. I mean, if we had just done it like maybe like everyone doing everything, it would have probably taken a lot longer.
Because everyone's doing different parts, that's why at the end we can bring it together and it's more easier to finish at the end.
It's a really useful way of showing them, in my mind, what the real world is like. You know, we don't work in isolation. We don't do things on our own or with our friends, or we do things with people we know kind of. We have a kind of working relationship with them. We work in teams and the teams have to communicate with other teams. So it gives them a proper sense of what working in the real world is about.
I think educationally it's absolutely essential that pupils do learning and work that is real, that's based in the real world. And if they can actually use their school community, their school resources to produce something which is of value to the school, then you've achieved a really significant educational objective.
Normally it's like out of textbooks and all that and stuff like that, and this is really fun because it's like doing something real, if you know what I mean, like problem solving.
Okay, I'd like you to share the ideas behind the skills you've been using. The skills you've used today, how you could be improving your learning, and again, another link to other subjects.
STEM learning is by its nature cross-curricular and by its nature embedded in the real world. We want pupils to have an opportunity to take part in real activities, and the Futures material provided a real bedrock for that we could build project work from.